We are the only known intelligent life in the universe. Imagine that we're the only place with intelligence in this galaxy. Astronomers around the world are in awe of this groundbreaking discovery. The James Webb Space Telescope, JWST, has captured the elusive glow of city lights from an incredible distance of 7 trillion miles from Earth. This achievement exceeds all expectations and does more than just expand our knowledge of the universe. Speculation is rampant as scientists examine the data, searching for clues that could unlock the secrets of these mysterious celestial beacons. The implications are staggering, suggesting that we are not alone in the universe and that it is teeming with life and activity far beyond our current understanding. Could these distant lights signify the presence of extraterrestrial cultures? What does this mean for our understanding of the likelihood of life beyond Earth? Launched into orbit on Christmas Day 2021, the JWST aimed to surpass the long-standing Hubble Space Telescope in capturing exceptionally sharp images of newly discovered celestial objects, planetary systems, and more. A scientific goal of the JWST is to study the formation of the first galaxies by peering into the distant regions of the universe. This is feasible because light travels through our universe over billions of years. When the JWST collects light, it observes these objects as they were billions of years ago. Astronomers use light years to measure distances, representing the maximum distance light can travel in a year. The team's initial graphic emphasized this, presenting a deep field image on July 11, 2022, which was unveiled by U.S. President Joseph Biden from the White House. The Hubble Space Telescope previously focused on a small region of the sky for 10 consecutive days starting December 18, 1995. This deep field approach gained fame as the chosen area was a mere microscopic, about 1/1,000,000th of the entire sky. Most of the 3,000 previously undiscovered objects found by Hubble were galaxies located billions of light years away. With its focus on the SMX 0723 galaxy cluster, the JWST's deep field image covers a similarly small area of the sky. The SMX 0723 galaxy itself is 4.6 billion light-years away, and the more distant galaxies behind it are magnified by its powerful gravitational field, causing the background galaxies to be distorted into large arcs where the gravitational field is strongest. In one instance, it was determined that it took the light from a distant galaxy 13.1 billion years to reach the telescope after traveling through space. The light being released stretches as the universe expands. The main target galaxies of the JWST have stretched visible light from their stars into the infrared spectrum. Astronomers can directly compare JWST views with visible light photos of nearby galaxies taken by Hubble and other telescopes. By gathering data at these wavelengths, scientists can demonstrate how galaxies have evolved over cosmic time, enlarging and consolidating into the structures we observe today. Even more astounding than the sheer number of galaxies in the JWST's first deep field image is how quickly it was captured, in just a few hours compared to days. Practically wherever it searches, the JWST finds galaxies. Galaxy clusters are not the only objects acting as magnifying lenses. Scientists used the JWST to capture an image of a pair of galaxies designated VV1191 to study how the light from one altered as it passed through the other. The results of this investigation could reveal properties of the intervening galaxy's dust. It seems the JWST may have made a groundbreaking discovery: auroras on a so-called brown dwarf. The lack of a host star and the frigid temperature make it challenging to pinpoint where the energy in the upper atmosphere is coming from. However, it is believed that the object releasing the auroras is expelling methane. On Earth, auroras are created when energetic particles from the sun are captured by our planet's magnetic field. These charged particles travel to Earth's atmosphere via magnetic field lines near the poles, where they collide with gas molecules to produce a beautiful light display known as the Northern Lights. Jupiter and Saturn experience similar auroral phenomena due to the solar wind, but the brown dwarf W1935's auroras remain a significant mystery. Hope continues to rest on Proxima Centauri and TRAPPIST-1, located just 4.4 light-years from Earth within the Milky Way galaxy. Scientists have detected the presence of water on exoplanets in this system, raising the possibility of life. Just last month, the JWST discovered another supermassive black hole that was red in color and devouring everything around it. This discovery, which is 40 million times the size of the Sun, might not bode well for us. This massive black hole is rapidly consuming everything in its vicinity. Dr. Lucas Fu and Professor Al Zitran from Ben Gurion University in Israel led this discovery. According to their findings, the supermassive black hole is approximately 40 times heavier than the Sun, making it a gigantic monster in comparison to the galaxy it resides in. Fortunately, it is not close to Earth or the solar system, being 129 billion light-years away. However, it is approaching us, with the black hole consuming matter around it at a rapid rate. Its reddish color indicates it is enveloped in a thick veil of dust that obscures most of the light from passing through. When the JWST began transmitting its initial data, scientists were thrilled. Among the data collected for the Uncover program, 3 small objects with a crimson glow drew attention. We immediately suspected these were quasar-like objects. Supermassive black holes at the centers of galaxies are continually accreting material, and due to their red dot appearance, the entire galaxy's luminosity cannot be confined to a spot no larger than a modern star cluster. We were able to obtain precise size constraints due to the source's gravitational lensing. Even if all potential stars are compressed into that tiny area, the black hole still accounts for at least 1% of the system's total mass. The discovery of similar behavior in multiple additional early universe supermassive black holes has provided insights into the growth of both the black hole and the host galaxy, as well as their interactions, which remain largely unknown. For instance, whether supermassive black holes form from stellar remnants or primordial cosmic material collapsing into black holes is still uncertain. Additionally, the images transmitted back to Earth by the James Webb Space Telescope reveal some other rather unusual phenomena. Every night, we have the privilege of gazing into space and being captivated by the dazzling lights of planets and stars that float across the universe, countless light-years away. Moreover, the JWST allows us to see much more than our eyes can detect. For example, a question mark in space. For the past 20 months, the JWST has been traveling through space, sending back images of what it has found in deep space using its state-of-the-art near-infrared camera. Recently, answers were provided regarding a peculiar-looking finding in one JWST image, which focused on something completely different. The image was released by the European Space Agency and showed 2 young stars forming 1,470 light-years from Earth. However, there was a small orange mark at the image's base that resembled an inverted question mark. This mark is not tiny. In fact, it's enormous. The question mark was captured while observing the pair of young stars, dubbed Herbig-Haro 46 of 47. These cosmic beauties are surrounded by massive disks of dust and gas, with the entity itself being only a few thousand years old. The question mark shape may appear due to the two-dimensional nature of the image presented by the JWST from its specific viewpoint. At this point, we don't know what it is, and without further research, we might never know. However, experts have reviewed the findings, and it is most likely a distant galaxy or possibly interacting galaxies. The distorted question mark shape could result from their interactions, and we might be seeing something unprecedented. Determining its identity with any degree of certainty will require further investigation. With the abundance of distant galaxies revealed by the JWST, there is a wealth of new scientific inquiry. All eyes are now focusing on a specific set of Earth-sized planets that could hold the key to finding alien life close to home. The Fermi paradox, which highlights the absence of evidence for advanced alien life despite the statistically high probability of such beings existing, might finally be resolved. Some 40 light-years away from Earth and the solar system lies a star known as TRAPPIST-1, which has 7 planets orbiting it. In their quest to discover habitable planets, NASA considers a range of parameters beyond just planet size and distance from its star. A more effective approach would involve identifying the relative concentrations of specific compounds in a planet's atmosphere. This would allow researchers to determine if the planet is habitable. The Spitzer Space Telescope, part of NASA's space exploration mission, helped find the 7 rocky exoplanets orbiting TRAPPIST-1 6 years ago. The JWST has now measured the temperature of TRAPPIST-1b, one of those worlds. This is the first detection of any form of light emitted by an exoplanet as small and cool as the rocky planets in our solar system. Previous telescopes lacked the sensitivity to measure such faint mid-infrared light. Astronomers were thrilled when they first learned about the 7 TRAPPIST-1 exoplanets because these distant worlds are all approximately Earth-sized and located in the habitable zone, the region where planets can have liquid water on their surfaces at an ideal distance from their star. The system is considered an excellent laboratory and one of the best places to study rocky planet atmospheres. However, don't get too excited about a new world for humans just yet. The TRAPPIST-1 planets are currently out of our reach, being approximately 40 light-years away from Earth. These 7 planets orbit an M-dwarf star, which is much smaller and redder than our Sun. M-dwarfs are more common in the Milky Way galaxy and have a higher likelihood of hosting rocky planets, making them ideal targets for future observations. Despite this, M-dwarfs are highly active stars that emit harmful high-energy rays. This high level of stellar activity could potentially strip any atmosphere from the planets or make their atmospheres unsuitable for life. Thus, any potential habitability for the TRAPPIST-1 planets is still unknown. In earlier observations, scientists were unable to determine if TRAPPIST-1b had an atmosphere. This planet is tidally locked, meaning one side is always facing its star, while the other side remains in constant darkness. If the planet had an atmosphere, simulations suggested it would have a more even temperature distribution across its surface. However, the JWST's observations showed a higher temperature on the star-facing side, implying that TRAPPIST-1b likely lacks an atmosphere and is thus not considered potentially habitable. Nonetheless, the exciting aspect lies not only in TRAPPIST-1b but in the JWST's capability to make such observations. This breakthrough enables us to explore the atmospheres and temperatures of numerous other worlds. The JWST continues its mission of cosmic exploration, including detailed weather mapping of distant planets. For example, it has studied WASP-43b, a planet located 280 light-years away, revealing extreme temperatures and rapid equatorial winds. The JWST confirmed the presence of water vapor on the planet's day side, while previous telescopes had only suggested cloud cover on the night side. The JWST's precise temperature mapping of WASP-43b's various sides underscores its sensitivity and stability. The rapid winds on WASP-43b prevent the production of methane, showcasing the JWST's crucial role in investigating distant worlds. In recent years, space exploration has taken a remarkable leap forward, with the James Webb Space Telescope, JWST, leading the charge in unveiling new cosmic phenomena and deepening our understanding of the universe. The telescope's advanced instrumentation and sensitivity have allowed it to capture unprecedented details of distant galaxies, star clusters, and exoplanets, providing a wealth of new data that is reshaping our knowledge of space. One of the most significant achievements of the JWST is its ability to observe the universe in the infrared spectrum. Unlike its predecessor, the Hubble Space Telescope, which primarily observed visible and ultraviolet light, JWST's infrared capabilities enable it to peer through cosmic dust clouds and observe objects that are too faint or obscured for other telescopes. This has led to groundbreaking discoveries, such as identifying early galaxies formed shortly after the Big Bang and tracing their evolution over billions of years. In addition to studying distant galaxies, JWST has also provided new insights into the formation and life cycle of stars. By observing dense molecular clouds where stars are born, the telescope has revealed intricate details of star formation processes and the interactions between young stars and their surrounding environments. These observations are crucial for understanding how stars like our Sun come into existence and how they influence their planetary systems. Another area of focus for JWST is the study of exoplanets, planets orbiting stars outside our solar system. The telescope's ability to analyze the atmospheres of these distant worlds has opened up new possibilities for detecting signs of habitability. For instance, JWST has been able to identify specific molecules in the atmospheres of exoplanets, such as water vapor, carbon dioxide, and methane. These discoveries are essential for assessing the potential for life on other planets, as certain chemical signatures could indicate the presence of life-sustaining conditions. The JWST's observations have also shed light on the complex dynamics of galaxy mergers and interactions. When galaxies collide, they can trigger intense star formation and create massive structures such as starbursts and active galactic nuclei. By studying these processes, astronomers can gain a better understanding of how galaxies evolve and grow over time. The telescope's high-resolution imaging and spectroscopic capabilities allow scientists to investigate these phenomena in greater detail than ever before. Beyond its scientific contributions, the JWST has also been instrumental in inspiring a new generation of astronomers and space enthusiasts. The telescope's stunning images of distant galaxies, nebulae, and star clusters have captivated the public and highlighted the beauty and complexity of the cosmos. These images not only serve as valuable scientific data, but also foster a sense of wonder and curiosity about the universe. As the JWST continues its mission, it is expected to make even more groundbreaking discoveries. The telescope's ongoing observations will provide critical data for upcoming space missions and research initiatives, further advancing our understanding of the universe. Additionally, JWST's findings will contribute to the development of future space telescopes and observational technologies, paving the way for even more detailed and comprehensive studies of the cosmos. In summary, the James Webb Space Telescope represents a significant leap forward in space exploration and astronomy. Its advanced capabilities have allowed scientists to explore the universe in unprecedented detail, uncovering new insights into the formation of galaxies, stars, and planetary systems. As the JWST continues to operate, its discoveries will undoubtedly expand our knowledge of the universe and inspire future generations of astronomers and space explorers.